Okay, so here's E15. This is the last phase of cycle E. And this is having to do, I just wrote here double chain rule. So far we've only been using chain rule when there's one inside function and one outside function. But what you're going to see is that there could be several inside functions. So there could be one function inside of another, which is inside of another, which is inside of another. And so we're going to do examples like that. So here's the first one. We're going to find the derivative of this. So the first thing that you want to do is, if you've got like a trig function raised to a power, I would just rewrite it. You know, put the trig function in parentheses and the power outside. And okay, so what we've got here, guys, when you do like this thing, all right, when you're looking for the innermost function, look at x. Okay, so I look at this x. What is the very first thing? So when you're finding the innermost function, you look at the x, and then you say to yourself, what is the very first thing that is happening to this x? The very first thing happening to this x is that it's being cubed. So the innermost function is x cubed. But then, what is this x cubed? Then what is happening to this x cubed? The next thing that's happening to this x cubed is that it's being put inside of a cosine function. So that is inside of cosine of blank. But then, what is happening to the cosine function? It's being squared. All right, so here you really have like two insides. And then we've got like that outside. So you take the derivative of like each of them. So what's the derivative of x cubed? 3x squared. What's the derivative of cosine of blank? It's negative sine of blank. What is the derivative of blank squared? 2 blank to the first. And then what goes back inside of these things is like what used to be inside of the original parentheses. So this parenthesis, so what was in this parenthesis has to go in this parenthesis. All right, so what was in this parenthesis is x cubed. All right, and then what was in this parenthesis goes into this parenthesis. What was in this parenthesis was a cosine, and then inside of that cosine was an x cubed. So it goes cosine and then x cubed. All right, and I'll do another one. So we get that y prime is negative 6 x squared sine x cubed cosine x cubed. All right. I think it's like a satisfying process. Okay, now this next one. So y is tangent cubed of radical cotangent of 7x. So let me convert this. So this is tangent of cotangent 7x, but it's this whole thing is being cubed. I don't know why I capitalized the T up there. All right, so now let's find out, like, let's separate like all of the functions. So we're basically, this is called what I'm doing up here is called a decomposition. Okay, so to find the innermost function, you look at the x. You look at the x and you ask yourself, what is the very first thing that is happening to that x? The very first thing is it's being multiplied by 7. That means that the innermost function is 7x. Then you ask yourself, what is happening to the 7x? The 7x is being put into a cotangent function. And then you ask yourself, what is happening to this cotangent function? This cotangent function is being put into a square root function. So I'll go blank to the 1/2 for that square root. Then what is happening to this square root function? It's being put into a tangent function. And then what is happening to this tangent function? It's being cubed. So blank cubed. So we really got these 3 inner functions, and then that is the outside function. All right, so what's the derivative of 7x? It's 7. What's the derivative of cotangent? It's negative cosecant squared of blank. All right, but what goes back? But these blanks have to be like the same. All right, so whatever was in this blank goes in this blank. So it was a 7x. All right, then this, okay, so the derivative of this one is 1/2 blank to the negative 1/2. But what was in here has to go in here. So in here we had a cotangent, and then inside of that a 7x. So cotangent of 7x times. Okay, the derivative of tangent is secant squared of blank. So what was here has to go in here. So what was inside of here? It was the radical of the cotangent of 7x. So I'll put it back like that. Okay, and then times the derivative of this is 3 blank squared. And guys, let me just say, there's usually not this many insides. Usually the most we do is like a double chain rule. All right, I've never seen anything more than that on an AP test, I don't think. Okay, and then what was in here is what has to go back here. So what was in here was a tangent, and then inside of that was a radical, inside of that was a cotangent, and then inside of that was 7x. So, oh crap, wow, that's kind of a lot. So I'll just go like this. So that's tangent, radical, cotangent, 7x. And on your practice even, guys, there's nothing this involved. I just wanted you to see how complex it can get. So we've got that y prime is equal to, all right, all of this is being multiplied. So I've got 7, a negative, a half, a 3. So what? So 21, negative 21 halves. Negative 21 halves. Oh, wow. And then this is cosecant squared of 7x cotangent of 7x to the negative 1/2. I just don't like how this is looking. And then secant squared radical cotangent of 7x. And then tangent of radical cotangent of 7x all to the second. Holy cow, wow. Yeah, so guys, even though you're probably not you're going to see something like this on the AP test, or even on a test that I give you, or even on the practice, to be able to do, if you can do something this involved, then you have mastered chain rule. Like there is you've got no obstacle there. All right, guys. So that is the end of the cycle. All right, I'll talk to you later.